Question 3 is assessing your ability to factor higher degree polynomials using the factoring by grouping method. Okay. All right, question 3 reads, when factoring to reveal the roots of the equation x to the third plus 2x squared minus 9x minus 18 equals 0, which equation can be used? All right, so what we're going to do is we're going to proceed to factor this cubic with 4 terms in 2 different ways and see which one matches the steps, the options that we have here. All right, so we'll get started by factoring this cubic with 4 terms just the way it is first, and then we will interchange the middle terms and factor it out again and see what we get. All right, so x to the third plus 2x squared minus 9x minus 18 equals 0. Okay, so we have 4 terms here. If we want to factor by grouping, what we're going to do is we're going to divide it right down the center. Okay, so we're going to form a partition right down the center like that. So factoring by grouping means we have 2 terms in the left side of the partition that forms a group, and then the last 2 to the right forms another group. Alright, so just to give you a visual indication as to what I'm doing, let's use a parenthesis to help us out here. So for the first 2, we have x to the third plus 2x squared, and then I bring down this minus, and then for the next 2 I have quantity 9x. Now freeze for a second. If you put a parenthesis there, it is as though I have factored out the minus out of these 2 quantities. And guess what happens? When you factor out a minus, signs change. This was negative 9x before, now it's positive 9x. This minus 18 becomes positive 18. Alright, so anytime you have a negative in the center when you're factoring by grouping, you want to proceed with caution. Make sure that you invert the signs when you pull out a minus. Alrighty? Okay. So we're going to go ahead and factor out the GCF. Now something to remember concerning factoring out the GCF. You want to remember that when you factor out a GCF, what is it you're doing in essence? When you factor out a GCF, what you're doing is you are dividing out that GCF. You're dividing by that GCF. That's what factorization is. So just to illustrate, in this particular case, we factored out a minus. So what we were doing in essence is that we were dividing these 2 terms by negative. That's why these signs change. Alright, because when you divide by negative or multiply by negative, the sign changes to the opposite. Alrighty, okay, now let's go ahead and factor. From the first 2, we have x to the third and 2x squared. Okay, so let's put a 1 here. Alright, so we're going to pull out our common factors, okay? So for x to the third and x squared, what is the greatest common factor there? You look at the powers, whichever one is smaller, that's going to be the greatest common factor. Alright, and then for 1 and 2, you can just pull out a 1, or you just leave it alone. Alright, so let's go ahead and pull out the GCF for x to the third and x squared. The smaller of the 2 is 2, so we're going to factor out x squared. So what does it mean to factor out x squared? To factor out x squared means we're going to divide these 2 by x squared. When you divide x to the third by x squared, what happens is that the power is going to reduce by the power of the term you factored out. So since you factor out x squared, this will be reduced by 2 and is going to be left with 1. And then this one is going to be reduced by 2, so the power is going to be 0. And anything raised to the 0th power other than 0 is 1. So this x squared becomes 1. The entire x squared is divided out. Okay? And then as for the coefficients, you can put a 1 there, but it doesn't really matter if you do or don't. Okay, so what do we have left? X to the third has lost 2 of its powers, so it's going to be left with x. So we have x plus, and then we just left with 2 here, then minus. Now let's look at 9x and 18. Is there a common factor that we can pull out? What is the biggest number that goes into 9 and 18? 9, right? So we pull out a 9, factor out a 9. So we're dividing by 9. That's what factorization is. So 9 goes here 1, and then 9 goes into 18 2. Okay, and then we're left with negative 9, and we have x plus 2 equals 0. Okay, and then just to make sure we did it correctly, you want to take a look at the terms in the parentheses. Are they identical? If they're identical, that's an indication that your factoring by grouping steps were correct, and that's the case here. Okay, so we factored by grouping. We're not done yet, but let's check and see if we have a match at this time. X squared times x plus 2 minus 9 times x plus 2. That matches with option number 1. So this can be used to reveal the roots of the equation. If we complete the factorization process, this is how we do it. What we do is we take the terms that have identical values, these two identical quantities right here, we factor them out as though we're dividing out. So we're going to have x plus 2 factored out, and then x squared and negative 9. Guess what we do with those two terms left behind? Those two terms left behind are grouped together in their own nice little parentheses. X plus 2 times x squared minus 9. Uh-oh, we have a problem here. If you look at option 3, it says x minus 2 x squared minus 9. There's a disparity with the signs here. So that automatically tells us that option 3 is not an equation that can be used. If you take a look at option 2, what happened is that the middle terms were interchanged before factoring by grouping. Okay? It doesn't change the factored form, the final factored form. It just reverses the product of the quantities. So let's go ahead and do that. I'm going to rewrite the problem, but I'm going to interchange the middle terms. Alright? So it's going to be x to the third plus 2x, no, 2x squared, I'm copying the same thing. X to the third minus 9x plus 2x squared minus 18 equals 0. Okay, so we're going to break it down the center, and we're going to factor by grouping. Alright, so for the first two terms, well, let's group them again visually so we can see exactly what's going on. So we have x to the third minus 9x grouped together plus 2x squared. Now you remember previously when we put the parentheses after the minus, signs were changing all over the place. But in this situation that we have here, do we reverse signs? The answer is no. It's only when you factor out a negative that signs change. Okay, so this minus will remain minus like that. Okay, so now we're going to proceed to pull out GCFs. X to the third and 9x. The power for x is just 1. So remember, when you're factoring out degree terms, you take the smaller power. That's going to be the GCF. So x to the third and x to the 1. The 1 has a smaller power, so we factor out x to the first power. Okay? And then we're going to subtract this power from these two powers. What happens to x to the third is that the power goes down by 1 to become 2. So we're left with x squared. So let me just illustrate to you what I'm talking about, the division process. X to the third divided by x. What's happening is that if we break it down, x times x over x to the 1, this x right here just takes out one of the factors. Okay, so whatever the power of the denominator is, it takes off that much power from the numerator, or the degree that you're dividing by. So that's why you end up with x squared. Alright, so that's why we have this right here. But when you have x and x, identical powers, guess what? They take each other out completely. And then you are left with x squared minus 9. Okay? Now on the right side of the partition, 2 and 18. What is the biggest number that goes into 2 and 18? The answer is 2. So you factor out 2. And then now we're going to divide by 2. Okay? So 2 goes into 1, and 2 goes into 18 9 times. And we are left with a 1x squared minus 9 equals 0. Alrighty, so here we freeze and check again and ask ourselves, the quantities in the parentheses. Are they identical? They are, so that shows that our factorization process is accurate. Now let's see if we have a match here. X times x squared minus 9 plus 2 times x squared minus 9. Option number 2 is absolutely correct also. It can be used to reveal the roots of this equation right here. Alright, so the answer to this question is option number 1. Okay? Alright, so what we're going to do is we're just going to finish the problem off. The question doesn't ask us to do it, but I think it's important that you know how to solve equations of higher roots, okay? So if we want to factor this one, we just factor out the x squared minus 9, and we're left with x plus 2. Since multiplication commutes, this equation is exactly equal to this equation. The factors are written in reverse order, but since multiplication commutes, it doesn't matter the order of the product of the factors. Alright? So next we use the zero product property and set both factors equal to 0 and then solve for the roots. So here we just add 9 to both sides, equal 9, and then we take the square root, and then that gives us x equals plus or minus 3. Remember, anytime you take the square root of a square, you have to introduce a plus or minus sign. And then over here, you subtract 2 from both sides, x equals negative 2. And your roots are, in roster form for sets, negative 3, negative 2, and positive 3. And that, ladies and gentlemen, is your